Hello everyone, welcome to this video. This is a lesson on the configuration of basic switch management. Really sorry about the delay in getting this video out. It should have been released quite a while back, 3 weeks ago. So please do forgive me here. I've got all the videos which haven't been released as well. I'm trying my best to get these out as soon as possible. So thanks for bearing with me, guys. So what we're going to be covering in this lesson. So there's 5 parts to this lesson. Firstly, securing user mode with securing user mode and enable mode with simple shared passwords. Then we were looking at securing securing with the local username and password pair. Then securing using external authentication server, securing using secure shell SSH, and securing the web user interface. So it's quite a bit to get into. 5 parts for this lesson. So first, I just want to talk about default Cisco switch catalyst switch behavior. When it comes to accessing via telnet and SSH is different to console. So when it comes to console access, by default, you've kind of like you basically as an administrator will be able to access user mode, privilege exec mode without username password prompts. No username password prompts. But for telnet is very different. This kind of behavior kind of makes sense if you think if an engineer has physical control over a switch, then for him to have very unrestricted access to the switch in terms of virtual access by default, it kind of makes sense. If you physically with the switch, you've got physical control of it. You could have the ability to pull the power cable. You can turn the, you can switch if there's a switch. If you can just flick the switch off with an on-off switch, you can turn the switch off. You can pull the SFP module right out the switch. You can unplug Ethernet cables out the switch. You've got physical access over it. You don't even have to shut down an interface. You can just yank an Ethernet cable out. So if you have physical access, it kind of makes sense for you to have quite unrestricted console access to it. Virtual access. So your ability to go into user mode and privilege exec mode without being challenged. Then moving on to telnet and SSH users, very different. Is quite locked down the access for these types of users, unless someone specifically, an engineer specifically specifies, opens a virtual terminal line and specifies access for telnet or SSH or both. You're not going to be able to go in and even get you won't be able to log in using telnet and SSH. And let's look at the first type of way we can secure switches, which is securing user mode and privilege mode with simple passwords. So in this case here, you got young Claire. Young Claire is a Cisco enthusiast. She lives in London, England, okay, my country, and she loves Cisco. She has a switch in her home, and she connects to it via console cable, but she wants to add a little bit of security. She wants to take a bit of extra care and add security, some password security. So what she does is she configures line console 0, login. She goes in privilege. She goes into global configuration mode, types in line console 0, then enter, login, enter, and then specifies a password, which is Big Ben. So this is a password now for her switch for anyone accessing via console. Now, across the pond, we've got Tim. Now, Tim has a switch, and Tim has Tim's switch is here, and Tim uses Tim wants to configure password switch for it. So line. So it goes into global configuration mode, line VTY 015, login, and uses the specifies password, also Big Ben, and transport import all. Transport import all, which allows access for this is kind of it's a bit ambiguous. It allows it allows SSH telnet access. You could just do transport import SSH, for example, but in this case, transport import all is allowing access from telnet and SSH. So Tim has now basically what he's done here is configured a telnet password for accessing via telnet, Okay, so you'll see now in this so if he was to log in, he'll be challenged with the password. Enter the password Big Ben, and then that would give him access to user mode. Same thing with Claire. She accessed via console. Now she'll be challenged for a password. She puts the password in, and that gets into user mode. But still an enable secret password to get into privilege mode. Or enable, it could be an enabled password. An enabled secret password is better, but that'll get you into privilege exec mode or enable mode if you want to call it enable mode. Now, that's okay, but there's a better way to do it is to have a username password pair rather than using simple shared passwords. So when it comes to, for example, here, Claire accessing via console, she can now create a username. So Claire is going to secure her console access, but what she's going to do, she's going to configure a username of Claire Secret Kensington. Okay, and then that's okay. So that's a username and a password there, and that is now configured. Okay, great. Well, not quite yet. That she's entered that. Then line console 0, login local, and then return to privileged exec mode, enabled mode. Now that's configured from console by console. So now she will be challenged for username and password when she tries to log into her switch. So across the pond in New York, Tim, like what? Tim, what's Tim doing? Well, Tim's Claire's friend, and Tim establishes a established a telnet connection to Claire switch, and so he's logged onto the switch, but he wants to set up a telnet username and password. So what does he do? Username Tim secret, and he sets his password as Broadway here. Line VTY015, so he's opening the virtual terminal line. Login local, transport import all, then return into privilege exec mode, enable mode, and now that's configured. So Tim has now configured himself a username and password to log into Claire's London switch here. Okay, but he had to open the virtual terminal line and then specify transport import all to enable him to be able to do this. To allow this. So that's what's happened here. Now let's move on here to I wanted to actually talk about this. So enable passwords are okay, not really secure though, as enabled secret passwords. So enabled secret passwords, you might see enabled passwords in older iOS versions, but enabled secret passwords are by far better. So these are definitely preferred to use an enable secret password. So let's now move on. So when Tim here logs on to the Claire switch next time, he's now challenged for that password. So start trying to so he puts in the IP address telnet 10.19 .9.9.19, and then he enters his username Tim, password Broadway. You can't see it because it's hidden, and then that now and then he's in enable mode, puts in the enable secret password. Now he's in global configuration mode, and then he returns into privilege exec mode by doing Control Z. So that's all well and good. Tim can connect to Claire's switch in London using using the username and password that he set, which is great. That's excellent. So let's now move on to securing user mode access with external authentication service. So what I just want to ask you guys what you actually thought about what we about what we did here. Username password pairs. I mean, cool, right? Sorry about that. The username password pairs. We have more security in the sense we're using a username with a password instead of just using a shared password. Okay, so that's great, right? it's good, but there's a problem because if you think about administration, let's say you've got an internet service provider, they've got like 50 engineers or need to access a switch. If you wanted to enforce some level of password security, um, if you wanted to enforce a level of password security on the switch, it wouldn't be so easy to do that when you've got 50 accounts on there, which are all, kind of individually managed. It'd be better to do it from a central location. So this is what's happening then. What we're doing is we can use AAA servers, and AAA servers are really cool because they just make our life easier. They do really make your life easier. So it's definitely recommended, for these kind of circumstances, to be using a AAA server. They do help a lot. So let's. I love AA service, authentication, authorization, and accounting service. They make administration easier, and they're storing the usernames and passwords. Awesome. Now moving on to method 4, securing remote access with secure shell. Now, Telnet is flawed. Telnet is not necessarily a friend because the data is flowing in clear text. Oh no. So what do we need to do? Because data can be compromised quite easily by a man in the middle of the attack, okay? So what we need to do is use something like use secure shell, SSH, because SSH does data encryption between the client server. And so let's look at an example of young Sam. Sam wants to configure SSH access for his switch. So in this case, the switch is called, he needs to specify a host name for this switch firstly. So he chooses Toronto switch 001, TOR-SW-001. IP domain name, specifies his domain name. In this case is example.org4892.com. Okay, just a random name. Crypto key, generate RSA. Okay, so there's 3 things he needs to do in tandem to be able to generate the SSH encryption keys. And then for the local username configuration, similar to Telnet, username, Sam, secret, and then specifies the password. So Niagara Falls 10 in this case. Line VTY 015, login local, transport import all. That will then configure this all. Now, you might not know, but the SSH, there's 2 types of SSH. There's SSH version 1, SSH version 2. SSH version 1, there's SSH version 2. So, SSH version 1, right, was released back in 95, okay? So, can you believe it, 30 years ago? That was 30 years ago. And that was the first version, okay? Released and it was created by a Finnish gentleman, and back in 1995. SSH version 1. Now, SSH version 2 was released in 2006, and it adopted new standards. It's not just like, oh, it's SSH version 1, but a bit better. It's kind of a complete rewrite of the protocol, and it in several ways improved on it, improving security, new features. For example, an improved 3-layer protocol structure, a negotiable hashing mechanism, and negotiable key exchange and encryption method. Negotiable key exchanges and encryption methods. And you'll see when it comes to encryption, the encryption methods were different in SSH version 2. It wasn't exactly the same as SSH version 1 because over time encryption methods were found to have vulnerabilities. So if you look at SSH version 1, for example, there were 4 encryption algorithms that were used. Firstly, data encryption standard. Okay, this was introduced back in 1977 and was finally deprecated in 2005. So almost about 30 years. It's by around about 30 years this was being used. But DES had its vulnerabilities in it, and so there were several encryption algorithms that were designed and were thought that could replace DES. It finally turned out that AES, an Advanced Encryption Standard, became the standard that would finally become DES's successor, and in 2001, not too long before it was finally deprecated. 3DES was an improvement of DES wasn't released too long after the original DES, and it applied the DES algorithm 3 times to encrypted data. But 3DES has now also been recently, well, I say recently, back in 2019, was deprecated from January 1st, 2024, it was disallowed by the national, I believe the NIST, National Institutes of Standard and Technology in the United States. So yeah, 3DES no longer used or allowed anymore. That's been deprecated as well. But these two were used with SSH version 1 as as algorithm encryption algorithms. IDEA, International Data Encryption Algorithm, was first described in 1991. This was one of the encryption algorithms that were thought could replace DES. The patents expired in 2012, and now the algorithm is basically freely usable for all types of uses. So IDEA was also used, and then finally Blowfish. That this was a symmetric 64-bit Kleebox cipher designed in 1993 by Bruce Schneier, and that was also thought could be a replacement to DES, but it turned out Advanced Encryption Standard became the official replacement. So these were 4 algorithms used with SSH version 1. Then when SSH version 2, obviously the main one is Advanced Encryption Standard, AES. But Blowfish has been used 3DES until its deprecation. CAST 128, which was an encryption algorithm that was first described in 1996, also thought could be a replacement for DES. It's currently used in something called Pretty Good Privacy, PGP. I won't go too much into that, but finally, Revest Cipher 4, also known as RC4 or ARC4, designed by Ron Revest in 1987. A stream cipher is known for its simplicity and its speed in software. However, there have been multiple vulnerability flaws which have been found, and that's led to its replacement, Revest Cipher 4 RC4. But it was very fast and it was very simple, and that's why it was loved in software. And let's finally look at the configuration of SSH access to a switch now. So this is an example. So we've got here SAM configuring trying to switch 001. So it specifies the host name. He has to specify host name. He can't just leave us. He's not just going to leave us switch. So right, specifies the host name. Okay. IP domain name. Specify the domain name. Crypto key generate RSA. Specifies 1024 bits. You could have it. If you would have it more, you would be this. Then the process takes longer for this to actually, basically actually configure. IP SSH version 2, so it's using version 2, which is better version, obviously. Line VTY 015, login local, transport import all, exit, and now finally you can Sam can log in. Sam can make his logins. So username Sam Secret Riverdove 2022. 22. Username John Secret Jupiter, spelled with special characters. So these are 2 logins there, SSH logins that have been configured here. So that's for configuring SSH access to a switch. Lastly, securing the web UI. Now, web UI, also known as the HTTP server of the Cisco switch. The web UI, HTTPS server, it's better to use HTTPS nowadays. But when it comes to configuring, we can secure with the username command. Now, these are some key commands. No IP HTTP server. This is to disable the HTTP server, and that's enabled by default. It's better to disable that. I think Cisco recommends that. It's better to disable this. IP HTTP secure server, that's to enable HTTPS, HTTP secure. That's the S in HTTPS. IP HTTP authentication server. This global command is going to define the authentication method to use locally defined usernames, and find username priority 15 password, and then a pass value. Actually specify your password, pass dash value. What is called here, but that's your actual password. So if you were to specify, for example, username Sam priority 15 password password Ottawa, for example, this will define the privilege level as 15, and as and that's very important, because when you have 15, you have two modes here when it comes to web UI: 0 and 15. And 15 is basically unrestricted access into the web user interface. So 15 will give you that full access, the global access to the web user interface. So that brings me to the end of this video. So thank you so much, guys, for watching. Really appreciate it as always. Please like, share, and subscribe if you found this video beneficial. Thank you so much for watching, and take care. Thank you.